So for the proportionality theorem, you must prove that they're saying AD over DB. This side over this side is proportional to this side, AE over EC. Okay. Oop. So these two lines, between these two parallel lines now, firstly just join, construct DC, right? And construct BE. Okay, what you must know, this that they give you proportionality theorem will always be your base of a triangle, right? So you see DB is one of the bases, so we had to make a triangle with DB as a base, and then EC also, so we had to make a triangle with EC. Okay, now this formula we're gonna work with area, and you know the area of a triangle is half the base times the perpendicular height, right? But how do we get the perpendicular height, the 90-degree angle? From this point, we're basically going to make a straight line onto the triangle, right? A 90-degree. That's a perpendicular height. Let's call that H. Okay, so let's quickly do the first one. So with proportionality theorem, they're giving us a triangle, so we're going to work with areas of a triangle to prove this, right? Like I said, this will always be your base. They want us to prove that the AD over DB. So let's start there. We say triangle AD and DB. Where's AD? AD is here and DB is here. Do you see that DB, this is the base, right? Let's figure out the triangle. E is the height. So we're going to say triangle DBE, right? And AD is the base here, and E is also the height. Now when 2 points have the exact same height, the exact same vertex basically, that's when the perpendicular height is exactly the same. If I had these two triangles, right, the height of this, the perpendicular height of this, is the same perpendicular height of this triangle as well. The height of this triangle it's always from the top point downwards, right? So this height here is the same as the height in this triangle, and that's where this comes from. So anyway, so ADE, the area of that over the area of DBE, right? Now you say we must prove they in proportion. So the area is always half the base. No? What is the base of ADE? It's AD. Half the base times by the height. Our height in this case is H, right? And then again for the area of triangle DBE, half, what's the base of DBE? This side. It's always this here. This will always be your base of the sky June. Half of DB, also times the height. And you'll see that H cancels out, half cancels out, and then you'll get AD over DB. You see, so you have the one part there already. Now we do the same thing for our new triangle. This triangle, the base is AE and EC. Where is AE's vertex? Can you see it's by D? And EC, it meets at D, right? So from D we're going to construct another height, another perpendicular height, and this height we're going to call K. You can call it anything, but yeah, it's prefer K. Once again, we prove this other proportional side, right? So now we start again with exactly what they give us, AE and EC. AE's height goes until T, so it's triangle AED, and EC's height also goes until D. You see that's the base, and there's the height, right? Okay, same thing, half the base times the height. What's your base? There, AE. Base here is EC. Just take it from that formula they already gave you. Where do they meet up? Where is its vertical point, basically the maximum height? It's D, right? Oh, sorry, yeah. It's D, sorry, and the height, it must half the base, there's the base, times the height. We call the height K. The reason why this is the height is because your height is from your base till your highest point. You see, the highest point there is at D, ECD, and the perpendicular height from there is this, which is K. So we're going to say half the base times the height, which is K, half the base times the height, which is K. Cancels out, you'll be left with AE over EC. Now you must prove these two to each other. We start with the top. Look, triangle ADE and AED is exactly the same triangle. So you can say the triangle You can say they're equal because it's common, right? Now you must prove these two triangles. So here we will say DBE and ECD is also equal to each other. Why? Because they have the same base, which is DE, and the same height. Because in two parallel lines, so how does this work? Basically, between two parallel lines, the height here and the height here will be exactly the same anyway, because those lines never intersect. The parallel lines, the distance will always be the same, right? So, and a common side of triangle ECD and triangle DBE is DE. Do you see? They all share that, so that's how going to be our base now. So they have the same base and also the same height. That's why we can say that these two triangles are equal to each other. You see? So now, then we can say now the area. Now we can say the areas are equal to each other. This is equal to this, because you basically prove now that the triangles are equal to each other there. And now we can put there. Therefore, AE over DB is equal to AE over EC. Because we found the area of this, it was AB over DB. So we're putting it just in the place of that. We found the area of that one as well, which was AE over EC. So then you prove it